Hey everyone, welcome to my IoT project. I'm going to be talking about Mamilla, an educational breastfeeding support device. So why is breastfeeding education important? UK has the lowest breastfeeding rates in the world, with only 1% of mothers continuing to exclusively breastfeed, and 8 out of 10 stating that they stopped breastfeeding before they would like to. Hence Mamilla was developed. This was a project that came out of the industrial designing engineering module, where two key features of an optimal latch was prototype to provide mothers a more sort of tactile learning experience. However, as this was an initial prototype, there was limitations, especially with the chin sensing. It was quite temperamental because we were using conductive paint, and also it was not flexible because it was hard 3D print, which is not very comfortable. Moreover, another envision feature that was not achieved was to capture the real-time motion of the device to provide mothers the guidance when they're using it with respect to the breast. So this is how I laid out the project objectives for my IoT system. So I wanted to capture both motion data and measure the deformation when chin to breast contact was achieved. Then this was used to record data for various correct and incorrect positions, which can then be used to train a machine learning model. And the machine learning model can help in actuating to provide real-time feedback for the mothers. And finally, also create real-time visualization so that the mothers can see what they're doing with respect to the breast when the 3D CAD moves. So how does the system work? The ESP32 microcontroller collects data from an MPU 6050 and a flex sensor via the I2C protocol and analog input. The sensor data is then sent to Python via the serial port, which creates CSV files, and these CSV files are used for data analysis and also to train a binary classification machine learning model. This then is communicated again via the serial port, which uses the classified data to send it back to the ESP32, and the ESP32 controls the LED to turn on and off based on correct and incorrect positions. Finally, the web application communicates to the ESP32 via the router using HTTP requests, which then shows the 3D visualization of the device moving in real time. So here's how the sensing worked, the proposed system on the right, and this is me just testing the flex sensor and the gyroscope to see how the values changes for different positions. Then the sensors were programmed using the Arduino IDE-Y library with a sampling frequency of 100 Hz. This was communicated to the serial port via Python, which recorded these into CSV files, and 400 samples were collected for each of these positions. After collecting the data, binary classification machine learning model was implemented. The model was trained with a decent training and validation curve and achieved an accuracy of 88%. However, it definitely needs improvement. Once the data is classified, it was sent back to the ESP32, which then listens to the data and controls the LED. So as you can see, the actuation has a delay in the response, and this is likely due to time taken for data processing and communication between Python and ESP32. Finally, the visualization was achieved using 3 libraries. So here's the Node3.js app that I created initially in the HTML browser. Then the gyro data was transmitted to a web app, which was controlling a simple cube. And finally, the CAD was then implemented, which moved in real time with the gyro data. Here's the final visualization video of the web app, and providing instructions and changing when a feature is achieved. As you can see, the IT system was implemented from end to end. However, there is definitely room for improvement. In terms of data privacy and security, currently all the data is stored locally on the device, minimizing exposure to risks. However, in the future, cloud-based storage could be useful if we're trying to share the data to lactation consultants so they can see what the mother is doing in real time and suggest areas for improvement. However, obviously this is very sensitive data, and it's really important that the data that is sent to the lactation consultant is encrypted securely. In terms of future work and scalability, this device can be used pre-birth and post-birth. So pre-birth, mothers can practice different breastfeeding scenarios, so they go into breastfeeding feeling confident. However, post-birth, when they face latching difficulties, the device is on hand to support them. So it's really important to personalize the app features based on the mother's needs. In terms of the design, the device is quite compact and requires careful weight distribution because it mimics the head of the baby essentially. So customizing the PCB is definitely necessary so that the electronics don't add too much weight. And scalability will require mass manufacturing to reduce costs, and customizable silicon inserts could be used to cater to different breastfeeding sizes. So, thank you so much for listening.